We have some small pockets of fast solar wind that are going to keep things lively, and we got a couple bright regions on the sun's far side that are rotating into Earth view, and one of them may be from solar cycle 25. Those stories and more in the news this week. This space weather forecast is sponsored in part by Millersville University. Come get certified in broadcast space weather. Visit millersville.edu/SWEN. Space weather this week is continuing to be a little bit calm since the solar storm we had last week. But as we take a look at our front side sun, never mind the moon passing right there, you can see that dark coronal hole in the south, but you can also see a few dark patches here and there in around the middle of the sun. That's from a coronal hole that's kind of collapsed on itself. But we do have from those dark patches, we're going to get sources of little pockets of fast solar wind kind of going pss, 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 pss at us here over the next few days. And that could bump us up to maybe active conditions at mid-latitudes possibly, but definitely unsettled conditions. It's going to keep things pretty lively over the next few days. Now, once we get through that, you can actually see on the east limb there, you can see a couple bright regions. Well, that's from some regions rotating in from the sun's far side into Earth view, and one of those regions might actually be a bright region from solar cycle 25, the new cycle. But we're going to have to wait for the next couple days to kind of get a better look at it to tell for sure. Luckily though, it's probably going to boost the solar flux up into possibly the mid-70s by about the beginning of next week. Switching to our M-flare threat meter, you can see the X-ray flux continues to be low, but if you notice, we're hovering just below the B floor now, and this has been a trend that's been continuing for quite some time. And this by proxy means that the solar flux is also rising just a little bit. We are hovering in the low 70s for solar flux, which means marginal radio propagation conditions on Earth's day side. And even with a spotless sun, we're not dropping into the 60s anymore, so this is really good news. Now, plus, because we do have the two regions that are going to be rotating into Earth view here over the next few days, expect that X-ray flux and also by proxy the solar flux to rise just a little bit, and we could see the mid-70s by early next week. So radio propagation should also get a boost on Earth's day side, and these conditions might last maybe a week or more. Switching to our solar storm conditions, you can see more than a week ago we were kind of sitting around quiet to unsettled conditions, and then suddenly on the 18th, wham, we got hit by a solar storm, and it was also coupled with some fast solar wind, and by the 19th, bam, do you see that? We actually reached storm levels, and this brought us some gorgeous aurora down to mid-latitudes for a short while, and then after that, as things began to settle down just a little bit, we still had that fast wind with us, and so we kind of bounced around between active conditions and unsettled conditions. Now, since then, things have begun to calm down and we're back down to pretty much quiet conditions, but this isn't going to last. We're most likely going to bump up to unsettled conditions and possibly even active conditions here in the next couple days because of those small pockets of fast solar wind that are going to be hitting us. So you aurora photographers, especially if you're at high latitudes, you get yet another chance to catch some good shots of aurora. On February 9th, just shortly after the Inouye Solar Telescope revealed the most detailed image of the inner dynamics of our Sun, the joint ESA-NASA Solar Orbiter spacecraft was launched on its way to get close and personal with our star. And where was Parker Solar Probe at this time? Making history yet again, with its closest flyby of the Sun yet, and no doubt recording more untold stories in its ongoing adventure. Now, although these three missions weren't originally designed to work together, an unprecedented collaboration has now begun. Each mission is unique. Parker Solar Probe is the first ever to fly through the Sun's atmosphere. The Inouye telescope, called the Microscope of the Sun, is providing ground-based imagery with a higher resolution than even the best space-based solar telescopes. And now, rounding out the three, is Solar Orbiter, that will fly out of the ecliptic plane where all planets in our solar system reside and look down at the parts of the Sun we've never been able to see, its northern and southern poles. Not only is Solar Orbiter the first spacecraft to image the poles, it will also be the first to accurately measure the Sun's polar magnetic fields. These polar fields are key to understanding how the Sun's dynamic engine functions, and it's what we call the solar magnetic dynamo. and how it generates the ever-changing solar activity we call space weather. Now, this is no easy feat. The last time we flew a spacecraft near the sun's poles was back in the 1990s. That spacecraft, called Ulysses, it flew at 80 degrees inclination, which is far higher than the 34-degree solar orbital will reach during its extended mission. But it discovered mind-blowing things about the solar wind that fundamentally changed scientists' understanding of how the sun works. And now, Solar Orbiter is poised to do exactly that, plus much more. In fact, not only will it give us unprecedented imagery, it will also be a crucial player in answering the question that Parker Solar Probe is already tackling, that of how the sun's corona gets so hot. As reported recently, the Parker Solar Probe has already discovered that near the sun's surface, small, fast jets of solar wind can overtake slower ones, thus causing the magnetic field that is glued to these different jets of solar wind to kind of fold back on themselves and kink. These switchbacks, as they are called, might very well guard the secret as to why the solar corona is so much hotter than the surface of the sun. Now, simulations of these switchbacks show they actually heat the solar wind as they move outward, but even the largest of them is seen to shred apart and disappear by the time it reaches about 40 solar radii. Now, in fact, scientists believe that this is why Parker Solar Probe is the only spacecraft that has ever observed them. Earlier missions to the sun, they've only reached in as close as about 60 solar radii from the sun. But with Solar Orbiter, we might actually find out more of the truth. Though not reaching in as close as Parker Solar Probe, Solar Orbiter will fly inside the orbit of Mercury to about 40 solar radii, which is right at the limit where these switchbacks exist. If Solar Orbiter can observe the final moments of these switchbacks, while at the same time Parker Solar Probe observes the solar wind at their birthplace, we could be so much closer to having a complete picture of how the solar atmosphere is heated. So it looks as though our sun might finally beginning to be revealing its closely kept secrets, and with solar activity expected to ramp up later this year, it is truly a spectacular time for space weather research. So what else does our sun have in store for us this week? Well, this is stereo A. It's our far-sighted monitor. You can see here's Earth, here's the sun, and here's stereo A staring at the sun from the side. And as you take a look at the sun from stereo's view and you look at the east limb, you can see a couple bright regions rotating into view off of stereo's east limb. The northern one, that seems to be the brightest one. That could be a solar cycle 25 bright region. Then there's also one in the southern hemisphere, but it kind of dies out. Now, as the regions continue rotating into stereo's view, you see yet another region emerging kind of at mid-latitudes, and it's sandwiching between the high region and that one. It's sandwiching a very small coronal hole. So we're kind of watching this grouping here, and as it rotates into Earth view over the next couple days, we'll be able to tell if the high latitude region ends up being one from solar cycle 25, which it looks like. Either way, this grouping is definitely going to boost the solar flux into possibly the mid-70s by early next week. So amateur radio operators and emergency responders, you're in luck. Looks like radio propagation on Earth's dayside is going to improve. Switching to our moon, we have now come out of the new moon on our way to a first quarter, and by the third, the moon will be about 50% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, you're going to need to check your local rise and set times. Switching to your solar storm conditions and aurora possibilities over the coming week, we are anticipating those small pockets of fast solar wind hitting Earth here in the next couple days. So at high latitudes, NOAA is expecting active conditions with up to about a 35% chance of a major storm. Now at mid-latitudes, we're only expecting unsettled conditions, but we do have up to about a 25% chance of active conditions. And these conditions will continue in through the weekend and possibly into the beginning of next week before things begin to settle down. So your aurora photographers, especially at high latitudes, definitely keep your batteries charged because you could get some chances for some decent aurora. Switching to your solar flare and particle radiation storm outlook over the coming week, everything is still in the green when it comes to big solar flares. We have a spotless disk right now, so there's no risk for radio blackouts. So you GPS users, you should continue to enjoy top-notch reception on Earth's dayside. Now we do have a couple bright regions that are going to be rotating into Earth view here in about the next 3 days or so. And so our solar flux, which is sitting in the low 70s right now, by the beginning of next week could possibly rise up into the the mid-70s. And this is great news for amateur radio operators and emergency responders. You guys might get some decent radio propagation on Earth's dayside, and those conditions could last maybe in through, I don't know, the end of next week or so if these regions stay pretty strong like they look like they're going to. Now also, because we're at solar minimum, we have a higher cosmic ray impingement than we normally would, and so you frequent flyers, and this does include aircrew who fly over 800 hours annually and fly at high latitudes and high altitudes, you are in the marginal range for radiation dose, and this does include prenatal passengers, so please take this into consideration in your flight plans. So although the space weather's been a bit quiet this week, it's going to get lively soon. We have some pockets of fast solar wind from a remnant coronal hole that's going to be hitting Earth here over the next couple days, and it could bump us up to active conditions. So if you're a aurora photographer at high latitudes, definitely expect to get a show. If you're at mid-latitudes, however, well, I don't know. Maybe if you're really dedicated, it might be worth going out over this weekend to take a look. But you might want to sit this one out because it's not going to be a strong show, and the aurora is going to be pretty sporadic. Now also, even though we don't have any bright regions on the Earth-facing disk at the moment, a couple bright regions are going to be rotating into Earth view here in the next couple days, and we are going to be boosting that solar flux up possibly into the mid-70s by early next week. So you amateur radio operators and emergency responders, expect to get some decent propagation on Earth's dayside. Now also, you GPS users, well, things are looking pretty good for you because we don't really have any super strong solar storms right now, and the solar flux is still looking pretty low. So as long as you stay away from those dawn dust terminators and away from Aurora, your GPS reception should be top-notch. I'm Tamitha Scove. Thank you for watching.